I'm here to talk to you guys about my path and how I ended up working in deep sea marine biology. I went to undergrad in Connecticut, as I said, and as an undergraduate I had pretty much no direction. I had 5 different majors at one point, and I actually wanted to go into psychology, which is when I took my first biology class since high school, and I was like, this is amazing, I want to keep learning this, I want to keep doing it. I had no idea I had such a passion for it until, I think it was my sophomore year of college, so I was pretty old. And I just spent, I was like 19 years old at the point. A lot of people know what they want to do then. So I spent the rest of college kind of playing catch up and trying to figure out how I could participate and do as many biological activities as possible. So I did some field work down in Brazil. I thought I really would like to see another place in the world and work with marine mammals. I got an opportunity to work with loggerhead sea turtles with Proyecto Tamar. So if you guys are interested in marine mammals, it's an awesome organization to check out, and you can go volunteer and do coastal research with them. They're a super awesome group. And then I also did undergraduate research on invasive crabs in Long Island Sound, and we set traps, hauled them, collected them, took all of their eggs off, you can see their eggs, and counted them. So I spent a lot of time counting. If you want to be a biologist, you need to learn how to count tiny things and not get bored doing it. So I thought that was great, and when I graduated, I moved up to Maine and worked for an environmental research institute. And I was a coastal monitoring intern, and that was really great because I got to be on a lobster boat pretty much every day, and we were taking water samples and sampling for invasive species. We rescued seals when they were stranded on the beach, and I got to work with invasive crabs and spent a lot of time counting, as you see. And there are a lot of perks to that. We got to go see like baby tern hatcheries, which you can see in the top right, and I also found cute little nudibranchs. We have them on the East Coast as well, so not just down here. And then after that, I was like, coastal research, great and everything, but people have been working on that for so long, and I saw a volunteer opportunity with the National Museum of Natural History in DC, and it was to work with their deep sea hydrothermal vent collection, and I was like, oh my god, I've always dreamed about working with the deep sea since I was in high school and saw that Planet Earth episode about the deep sea, and I've always wanted to get into it, and this was kind of the best way. So I wrote an application, was like, I know DC is an expensive place to live, I'll work extra hours as a waitress or something, and just try to get into this community, because that's one of the hardest things about sciences, is breaking in, meeting people, but once you're in, and you make those connections, it's really good. So I applied, and thankfully my old boss, who's turned out to be one of the best mentors I've ever had, she found money for me, hired me on, and I got to work in their collections. The Smithsonian's really amazing if you're a biologist. They have a huge collection of organisms from all over the world. I worked in invertebrate zoology, and I pretty much just found beautiful worms like this from hydrothermal vents. Do you guys know what hydrothermal vents are? Yes. In the deep sea. So when the plates are moving, there will be certain areas where they like hit together and crust up, and on those crusts there will be certain, you could just call them gaps, where gases like methane, just really, really nasty chemicals will seep through, and it's a very high temperature, and you're laughing at me? It's an extremely high temperature, and you wouldn't think anything could live there. But in the 1970s, using an ROV, or an AUV, no, an ROV, researchers discovered that there are animals all over these vents, and they can get up to temperatures of 400 degrees, and they're like, you just wouldn't think anything could be there. But instead there are these fantastic organisms that have found out how to live there with chemosynthetic bacteria. So you'll see all this white on this worm is a bacteria that helps it survive and feeds it, and so there's tons of these amazing organisms. And if you guys want to talk to me about these later, I have a lot of information. And then I got an opportunity to come out to MBARI last fall and collect for the museum, which means you go out into the field and you're looking for an organism, and we don't know a lot about it, so you kind of If you're on land, now you take a genetic sample with just a swab and a photograph. You don't have to actually collect and kill the organism. Unfortunately, with deep sea work, since you can't use your hands, you have to use an ROV, like the dog rickets, and suck up the organism with a vacuum-like thing or put it in a jar. And then when it comes up to surface, oh, you can see here's like all of the equipment that it's set up with, and that's the ROV dog rickets dropping down. This is what it looks like in the control room. As a deep sea researcher, you don't get to spend a lot of time outside. You are in the dark, you're looking at screens so much. It's not like playing in the water in the coastal region. You really have to want to be locked inside for a lot of the year, and it's expensive. So when you're out there doing your field work, you're spending like most of your time working. You're no time for sleeping really, and it's just constant like reviewing images, collecting organisms, taking genetic samples, taking photographs, and trying to map your data. But it's really exciting because where you're looking, most people have never seen. Okay, sorry, I just split it into two. So when I got to go with the Smithsonian and collect for them, I was looking for specific organisms that we had only recently discovered in 2005. And actually there's tons of these coastal organisms. They're very abundant. They're called acorn worms. They're hemichordates. You guys might have heard of them previously. But in the deep sea, they look completely different. You can see they're like very transparent, kind of hard to see. They're on what we call pillow lava. So this is where an underwater volcano has erupted and just created these really beautiful rock forms, and there's just a little bit of sediment, and these animals move all over those rock forms and slowly eat the sediment. So we pretty much were going around, and the geologists were looking at the rock forms, and I was like, oh, look at that worm, I really want to get that worm, do you guys have time to suck it up? And so when we would see them, we would look at them, suck it up, take a picture, came back into the lab, and remember you're on a boat the whole time, so when you're in the lab, like this, and you have to be, it's a different experience. You should definitely do field work if you think you want to go into this field to figure out if you like it. So I take a little piece of tissue, put it in ethanol, freeze it for later genetic analysis, and then I took some photographs because it's really important to know what these animals look like. Because once you fix them, they turn into like a gelatinous, not pretty or attractive thing, so it's nice to have the pictures. You can see this is one of the images I took of the organisms we collected. And another one, this is a swimmer, an acrocyanid polychaete. They're really cool, they swim in the water column, and they have these green bioluminescent stacks on their neck right here, which they kind of throw at their predators when they're coming at them to distract them and swim away. So other than deep sea research, I'm really interested in ocean conservation, and I got an experience to work and do research with microplastics. Have you guys ever heard of microplastics? Do you know anyone want to give me a definition? So it's pieces of plastic that are less than 5 millimeters, and there's even nanoplastics, so they're even tinier than that. And there's two different ways you can get microplastic. There's primary microplastics, so just input from the shore, so like microbeads, and have you heard about the microbeads in face scrubs and toothpaste and other exfoliating products? Yeah. And then there are these things called nurdles, which we use to ship across the ocean to build a lot of plastic products. So there are these teeny tiny little pieces of plastic that will be in ocean containers, and if those ocean containers fall off, that's a huge input of microplastics into the ocean. And then there's secondary microplastics, which is just like if a bottle breaks down or any plastic that's in the ocean, it doesn't, just because it's getting smaller, it doesn't mean it goes away. And you can find them throughout the entire water column. They've been found in the deep sea up to 4,000 meters so far in areas that have never been sampled previously by researchers. So it's a pretty big problem. Unfortunately, there's not a lot we can do in regards to collecting the microplastics out of the ocean. All we can do is stop the input, and the reasons we want to do this is because it's a really good way for invasive species to move around the ocean. They can latch onto it and drift through the water column. It's also really great for pollutants to latch on because it's I'm not going to go into chemistry. Basically, if there's a piece of plastic floating through the water column and there's a nasty chemical, the chemical will latch onto the plastic, and something like a zooplankton or another animal could eat it, and then when it's ingested, the pollutants will leach into the organism's body, and then if we eat that, like a mussel, say we go in and we're eating mussels, then we're getting a huge amount of those pollutants that were there. So things you can do to help with this problem is try to reduce the amount of plastic you guys use. So check whatever you use to wash your face. Make sure you're not using things with polyethylene microbeads in it, because pretty much if you wash it down the sink or in the shower or through your washing machine, it just goes straight to the wastewater treatment plant, and then it goes straight into the ocean from there. We unfortunately do not have filters that can collect these yet. So people are working on it, and we need people like engineers to help make this not a problem. Another big thing, unfortunately, that people are just discovering is that fleece is a huge impact on microplastics. So every time you wash it, you lose about 2,000 pieces of plastic. So if you don't mind being dirty and not washing your fleece, that's a really great thing. The ocean would appreciate it. And a huge thing you can also do as young scientists or just people who are interested in conservation is citizen science opportunities. There's a lot of organizations, especially in this area, that need your help, and we really appreciate it, and it's a great way to get involved, get field work, and see if you really like it. So say you're out swimming in the Monterey Bay and you see a jellyfish, you can go on jellywatch.org and report what it is that you see. And it's also fun because you get to take pictures of a lot of things, and that can be really good for developing a skill that you have. Additionally, there's great groups like Adventurers and Scientists for Conservation, so if you're traveling, you can check out this site and they will tell you about scientists who need data collected all over the world, and they'll just give you guidelines, and you can go and take a water sample or count how many marmots you see in a certain area and just report it back. So it's a fun thing you can do in addition to your vacations. So do you guys have any questions? Yes?
Why does the Smithsonian want you to collect odd little worms, and then what do they do with them?
Oh, absolutely. So the big thing, the collections at the Natural History Museum are really important because it's a way of marking biodiversity. So we have these collections going back to the 1800s, and we can kind of get a concept of like what's going on in the areas. Unfortunately, they started collecting prior to genetic information. So we have fixed a lot of the specimens in formaldehyde, which kills any genetic material. Now, the primary purpose of collecting is to describe these species. So if they're a new species, where do they fit into in the evolutionary tree? How do they exist in their environment? And so it's primarily a genetic collection now. Also, we have a lot of visiting researchers from all over the world who come and they're doing morphological studies, so they can go in and say they're interested in a type of crab from the Caribbean islands. They can go and they can take it out and look at what is called a holotype, which is basically the organism the species is described from. So whoever first found that species, they write down, the proportions of it, and it's like a perfect specimen. So you can compare to that and see, well, this one has 6 legs, but the holotype has 8, and reference.